Force, work and energy. In our daily life, we widely use the terms force, work and energy. All these terms are interrelated and somehow depend on each other. Force. In simple words, a push or pull acting on a body in order to alter its position is known as force. Force is that entity which has the nature to change the position of the object. In mathematical language, force is mass times acceleration. In terms of pressure, force is the product of surface area and pressure applied on it. We can find the application of force in our daily life activities. While playing cricket, we hit the ball by applying force using bat. The extent of applied force decides how far the ball will go. Similarly, while driving, we apply brakes to stop the vehicle. Pressure applied on brake pedal decides how long it will take to stop the vehicle. What force can do? A force can change the position of any object. A force can stop moving objects. A force can change the shape of objects. A force can change the direction of moving objects. Type of forces. Broadly, forces are divided into two categories. These are contact forces and non-contact forces. In nature, two forces act universally. These are frictional force and gravitational force. Frictional force falls under the category of contact forces, while gravitational force comes under the category of non-contact forces. Contact forces, frictional force, muscular force, mechanical force, etc. Non-contact forces, gravitational force, magnetic force, electrostatic force, etc. Gravitational force. Have you ever observed motion of a stone thrown vertically upwards? What happens? It comes back to the ground after a few moments. The earth attracts all the bodies towards it. This happens due to gravity of the earth. In fact, the earth behaves like a huge magnet and attracts objects towards its center. The force because of which this attraction or pull occurs is known as gravitational force. This force is universally applicable and found everywhere in nature. No more. Gravitational force of the earth is the key factor behind keeping the air in atmosphere. Activity. Aim: to understand dependence of gravitational force on mass. Need: 2 iron blocks of different masses, a spring. Method. Initially, take the lighter block and hook it with the spring. Lift the block vertically upward with the help of spring. Observe the elongation in length of spring and force exerted by block on your hand. Now repeat the process with heavier block. What will you observe? Observation: heavier block applies more force and elongation is maximum in the spring when we lift the heavier block. Conclusion: gravitational force depends on the mass. No more. Gravity on the moon is just 1/6 of that of the earth. That is why your weight will be 1/6 on the moon compared to the earth. Frictional force. What happens when we roll down a football on the ground? It comes to rest after a few seconds. This happens due to friction. The force which opposes the motion is known as frictional force. It is a force of contact nature and acts between two surfaces. Friction is found everywhere in nature. It acts universally between contact surfaces. Let's consider one more example. What happens when you stop pedaling your bicycle? It comes to rest after a few moments without applying brakes. This happens because of friction. From walking on the roads to riding in sheets, friction plays a significant role everywhere. No more. Frictional force always acts opposite to the direction of the motion. Amazing fact. Friction is responsible for wildfire. Is friction advantageous? Friction is usually known as a force which opposes the motion. At most of the places, friction acts as a negative force, but friction has a lot of advantages too. Friction enables us to walk, ride, stand, drive, run, etc. Friction also plays a key role in transmitting power. Work. When an object covers a distance in the direction of action of force, work is said to be done. In language of mathematics, work is the product of force and the distance covered by object in the direction of applied force. In actual, work is the output of applied force. Amount of work done depends on the magnitude of applied force. Work is said to be done only if there is a change in initial position of object. Suppose you are applying force on a wall. What happens? Wall remains in its place. Hence, work done in this case is considered to be zero. Let's consider another example. Suppose you are cycling in a circular path. You halted at the point from where you started. What should be the value of the work done? It will be zero because your initial and final positions are same. You traveled on the circular path, but mathematically you are on the same coordinates. That is why work done will be zero. Machines. A machine is nothing but an assist which lowers the human effort. A machine makes our work easier and saves a lot of effort. Machines are being used by mankind since ages. In a broad manner, machines are classified in two types. These are simple machines and complex machines. Complex machines are nothing but a combination of simple machines. Some of the simple machines are being discussed here. Lever. A lever is a form of simple machine which consists of a rigid rod fixed at a point around which it moves. A lever is used to cut things, in opening of cans and lids, and in lifting or moving of weights. Seesaw. Scissors, spoon, can opener, hammer are few examples of lever. Pulley. A pulley is an example of simple machine which consists of a wheel mounted on an axle or shaft to support the movement. A pulley can change the direction of movement and is widely used in power transmission. Pulley is mostly used in elevators, lifting weights, cranes, etc. Pulley is widely used in rural areas to draw water from a well. Wheel and axle. Wheel and axle is also an example of simple machine. It consists of a wheel connected to a rod known as axle. This axle is used to move the wheels. An axle passes through the center of wheels and helps to move or lift weights. Wheel of a vehicle, screwdriver, roller skates, etc. are few examples of wheel and axle. Inclined plane. An inclined plane is a flat sloping surface. It acts as a supporting surface tilted at an angle and is used to lift the load with ease. It is mostly used in construction and transport fields. An inclined plane connects a higher level to a lower level. Slides, slopes, escalators, etc. are examples of inclined planes. Wedges and screws also fall under the category of inclined planes. Screw. In actual, a screw is an inclined plane around a cylindrical shape with a sharp pointed end. Screws are used in fastening. Screwdrivers are used to tighten the screws. Screws are also used to hold things together, lift loads, etc. Bolt, vise, screw jacks are some examples where screw is used. Wedge. Wedge is another form of simple machine consisting of at least one inclined sharp end. This sharp side is used to cut things. Most common example of wedge is an axe. Energy. Energy is defined as the ability to do work. Energy is the basic need for any kind of work. If a task has to be performed, energy is needed there. Energy is the basic need for growth of all living beings. In nature, energy exists in various forms. All forms of energy are interchangeable. Some forms of energy are heat energy, solar energy, magnetic energy, nuclear energy, mechanical energy, chemical energy, electrical energy, etc. Sources of energy. The sun. The sun is the main source of energy on the earth. The energy received from the sun is known as solar energy. This solar energy is very useful for living beings. Plants prepare their food in the presence of sunlight by the process called photosynthesis. This prepared food is stored in chemical form by plants. During the photosynthesis, oxygen gas gets liberated into atmosphere. The sun gives us heat and light, which makes the earth a suitable planet for us. Vitamin D present in the sunlight is necessary for human growth. Solar energy is also used in generating electricity by means of solar panels. Energy stored in it can be further used for various purposes as per requirement. No more. Solar panel converts solar energy directly into electrical energy. This concept is used in street lights. Solar geysers are used by hotels to provide hot water to their clients. Water. Water contains huge amount of energy in moving state. This energy can be extracted and further utilized using various setups. Usually, water is stored in dams. The stored water contains potential energy. When water flows from a dam, its potential energy gets converted into kinetic energy. This energized water falls onto the turbine blades and rotates them. This is how electricity is produced. No more. Energy obtained from water is called hydroenergy. It is a clean form of energy and is renewable in nature. Wind. Moving air is called wind. Moving air has kinetic energy in it. This energy is very useful and is also used to produce electricity. Wind turbines are used to convert kinetic energy of wind into electrical energy. Wind energy moves turbine blades, which in turn rotates the generator. This causes electricity generation. Fuels. Fuels like petroleum, coal and kerosene oil contain energy in chemical form. They produce carbon contents after combustion. They are also known as fossil fuels. Chemical energy of the fuels can be converted into electrical energy as per our need. Atoms. All the things around us are made up of matter. Matter is made up of molecules composed of atoms. When atoms join together or break down separately, immense amount of energy is released. This energy is known as atomic energy. This energy is converted to electrical energy by using nuclear power plant. No more. Atom bomb and hydrogen bomb are based on the principles of atomic energy.